Hello everybody, welcome to Cam's Engineering. This is my new YouTube channel for all civil engineering softwares. Please subscribe. Like and share, thank you.
Today, I want to show you how to make a powerful subassembly from subassembly composer. Before we go through the steps how to make this interesting and powerful subassembly, let's first see what are the major uses of this powerful subassembly. Major use of all-in-one powerful subassembly. We call this subassembly all-in-one. All-in-one. And you'll decide this name is correct for this subassembly or not. You will decide it after finishing this presentation. Let's start from the first. This subassembly contains different type of ditches. Let's see. As you have seen it, it is a U-shaped reinforced concrete ditch. RC U-shaped ditch. But if you want to change this RC U-shaped ditch to masonry U-shaped ditch, come here and simply change the parameters here. You see? If you change it to masonry ditch, you can simply change this U-shaped ditch to masonry U-shaped ditch. You see? It's changed. And again, it's possible to change this masonry to trapezoidal ditch. It's also possible. You see? It changes to trapezoidal ditch. If you want to change again this trapezoidal ditch to V ditch, it's possible for this interesting subassembly. Simply by changing the width of this trapezoidal ditch to 0, it will automatically change it from trapezoidal to V-shaped ditch. Let's see. Yes, it's changed to U-shaped ditch. By the way, this subassembly contains also ditch insertion point. If you don't need it, you can make it 0. Again, for earthen ditch, it's possible to use this subassembly composer for earthen ditch. To change it to earthen ditch, just change the thickness of this trapezoidal ditch to 0. It will automatically change it from trapezoidal to earthen ditch. Yes, it's earthen ditch. One use of this subassembly contains almost 5 types of ditches in one subassembly. What is the other use of this subassembly? Let's see. It also contains undercut and replacement during our construction. If type of material is black water or expansive soil, there will be an undercut or replacement. And this subassembly also contains that. First, let's see the cut parts. In cut section, by the way, this subassembly contains 4 layers for the lane part, and again 4 layers for the shoulder parts. This one is in cut section, it's undercut replacement. 2 layers of undercut replacement for cut section. For flexibility purpose, the top one is selected replacement and the bottom one is rock replacement. And this subassembly also works for this subassembly, this undercut case. Even by changing this ditch types, it also works. You see, it works. This part for the shoulder and the lane parts, for as we talk, for flexibility purpose, 2 type of replacements, the selected fill replacement and rock replacement. But for the ditch part, this selected replacement, there is no need for this replacement and only the rock replacement here. It works. It works also for masonry, U-shaped ditch. What about fill case? Is during fill case, as we know, we have 2 type of replacement, either full width replacement or the toe side spar. This one, the toe side part replacement. If our fill height is greater than 2, mostly it's recommended here. This one, the toe side. By the way, this type of undercut and replacement, we call it balatoli, because the end part of the left and the right parts only undercut, and we call it balatoli. Therefore, if our fill height is 9, it's balatoli undercut. What about if we change this to, if our fill height is 1, it must be full width undercut and replacement. Then this subassembly also work. You see, it's changed from balatoli undercut and replacement to a full width replacement. That's why we call it all in one. What about the other use? It also works for different types of fill or cut material. Different types of fill or cut material. First, we'll see the fill part. In our subassembly, we have 3 types of fill slope: flat fill slope, medium fill slope, and steep fill slope. These parameters also shown there in Civil 3D, and they are changeable in Civil 3D. For time being, we did it for soil fill type. Fill slope, flat fill slope 3.1, medium fill slope 2.1, and steep fill slope 1.5 to 1. From if you want to change this fill material from soil to weathered rock or hard rock, you simply change these parameters, either here in subassembly composer or in Civil 3D. By changing these parameters, it's possible to use this subassembly for different type of fill materials. Let's check. Our fill height is 1. It is a flat fill slope. You see, it's a flat fill slope. What about our fill slope as 1.5? Our fill slope is 1.5. You see, it's changed from flat fill slope to medium fill slope. Again, if our fill height is 3, so automatically change it to steep fill slope. It will change. Yes, it's changed from flat fill slope to steep fill slope. For the cut part, for cut condition, it's 3. Again, here, yes, it's steep. Also, we gave these parameters for cut condition: flat cut slope, medium cut slope, steep cut slope. If our fill height, our excavation height is 3 meters, it's the steep cut slope. It's a steep cut slope. If it's changed to 1, you see, it's changed to medium fill slope. Therefore, it is useful. This powerful subassembly is useful for all type of materials, either soil or weathered rock or hard rock. You can use this subassembly by simply changing these parameters here in subassembly composer, or you can change it because it's visible in Civil 3D. You can change it, these parameters, in Civil 3D. By changing these parameters only, you can use this powerful subassembly for different type of rocks, fill or cut materials. Okay, let's see the other use. This subassembly also contains fill widening. Fill widening. Let's check this. Let's check this one. So we know if our fill height is greater than 3, the widening will start. But between 0 and 3, there is no any widening. If our fill height is 1, as you have seen it, there is no widening here. It's 0 widening. But if you change this one to -4, it will start widening, and it will 30 centimeter widening will be added here. Yes, it's added 30 centimeter widening here. If we increase this fill height to 7, it will be 6 centimeter. 6 centimeter widening. Yes, it's changed from 30 centimeter to 6 centimeter. If our fill height changed to 10 meter, it will be changed from 60 to 9 centimeter. Yes, it automatically changed from 60 to 9 centimeter. That's why it contains widening case. High fill widening case is also included here in this sub-assembly. What's the next use? It also contains benches with different type of bench slopes. Benches for different type of bench slopes. Let's change this to positive for cut condition. So we know our bench starts if our excavation greater than 10 meters. Then, as you have seen it, it's 9 meters. There is no any bench here. But if we increase our cut elevation to 11, if our excavation depth greater than 10, it will start the bench. You see, it starts the bench. If it's 30, it will add bench. You see, it will add bench. And the other thing, these benches are done by using loop. Therefore, you can use any number, any excavation depth. If you use 110 meter depth excavation, it's possible for this powerful subassembly to make the bench. You see, the bench for 110 meter excavation depth. It's possible for this subassembly. In addition to this, at one station, but with different bench slopes, from one to the other bench slopes, this powerful subassembly works for this scale. Therefore, it works for benches also. What is the other is shoulder super elevation. So we know it's difficult. Shoulder super elevation during super elevation case, but for this subassembly, there is not any problem for shoulders during the process of super elevation, because it's already calculated here. Our shoulder slope is calculated here in this flow chart. Let's see. You see, our shoulder is calculated here using if function. That's why there is no any problem for this subassembly during the super elevation case. The shoulder is calculated. Let's check during super elevation. This one is normal crown slope case is 4%. If I change this number to our maximum super elevation is 8. If our maximum super elevation 8 for lower case, our shoulder, you see, our shoulder also 8%. What about the upper case? If it's positive, it's positive 8. You see, if our lane is super elevation is positive 8, this one is 1% for drainage purpose only. Therefore, it's calculated shoulder case during super elevation, it's possible for this powerful subassembly. For the time being, it's enough to show you. I will release maximum of 2 videos how to make this powerful subassembly from the beginning to the end. How to make this one. I will release the videos, but my YouTube channel is new and this is my first video for YouTube. Please subscribe, like, and share. Thank you very much.
Thank you very much for listening, and please like, share, and subscribe.